On March 12, 2023, a powerful shockwave from an X-class flare on the Sun covered Earth. The SOHO spacecraft recorded a giant ejection of a fiery mass. Its expanding cloud was carried away towards Earth's orbit at an incredible speed, more than 2,000 kilometers per second. Only the fact that this eruption happened on the far side of the star helped us avoid a real catastrophe. But in the first 3 months of 2023, there were already 7 strongest X-class flares, and it's exactly the number of flares recorded for the entire past year. Scientists are seriously concerned about the unprecedented activity of the Sun. They attribute it to the star approaching the peak of its 11-year cycle, warning that it could become the strongest in history. So we definitely can't avoid destructive shocks. Ever since ancient times, people have noticed dark spots on the Sun, but it wasn't until 1852 that Swiss astronomer Rudolf Wolf noticed that the same dynamics occur on the Sun every 11 years. In the first 5 or 6 years, the number of sunspots increases, and having reached its maximum, it decreases for the same number of years. During each such cycle, the magnetic poles of the Sun change places. First, they're deformed because the star's layers rotate around their axis at different speeds. Then, dark spots form at the places of deformation. The larger they are, the stronger the flare will be, and the greater the likelihood of a coronal mass ejection, which is the ejection of plasma from the outer layer of the Sun. On September 1st, 1859, in the town of Redhill near London, astronomer Richard Carrington observed a group of such spots when he discovered an unusual flash of light that lasted about 5 minutes. Almost 18 hours later, a real rehearsal for the end of the world began on Earth. In the northeastern United States, dawn suddenly came in the middle of the night, and the brightest northern lights passed all over the world to the very equator, where it's basically impossible to observe such a thing. Telegraph equipment in Europe and North America sparked and ignited on its own, and the excess electricity in the air was so strong that messages from New York to Pittsburgh were sent automatically. Carrington was the first to not only record this colossal flare, but also link it to geomagnetic disturbances on Earth. The Sun had been erratic and flared up regularly for 5 full days prior. That didn't affect our planet, but prepared a corridor along which the solar mass ejection flew non-stop. That's why the charged particles didn't reach the Earth's magnetic field in 3 or 4 days, as is usually the case, but crashed into it directly in just a few hours. That provoked such a powerful shockwave. Almost 2 centuries later, electricity has become just as important a part of our lives as air. Therefore, the consequences of such an explosion today are scary even to imagine. Losses will be estimated in trillions of dollars, and it could take decades to repair the damage. But what if we just prepare for life without light and stock up on generators for a whole year? To answer this question, we need to figure out in what other ways solar flares can affect our planet. The main blow is taken by Earth's magnetic field, which, together with the atmosphere, protects us from cosmic radiation. The most powerful outbreaks can lead to the spontaneous combustion of de-energized power lines, but the Sun can hit us not only from the air. In 1972, more than 60 underwater mines off the coast of Vietnam detonated in a seemingly mystical way. In fact, they were equipped with magnetic fuses. Those had to respond to changes in the magnetic field due to a submarine's approach. But instead, they were triggered by a geomagnetic disturbance after the outbreak. Besides, the treacherous Sun is able to penetrate not only the magnetic field, but also the very crust of our planet. Experts from the National Institute of Geophysics and Volcanology in Rome compared 20 years of seismic activity with the SOHO data and came to some startling conclusions. They argue that solar flares can even trigger earthquakes of magnitude greater than 5.6. Positively charged plasma protons colliding with Earth's magnetic field create electromagnetic currents that propagate throughout the planet. Their impulses deform chords in Earth's crust and destabilize faults already close to breaking. Scientists believe that such mechanical deformations can cause earthquakes and tsunamis. But that's not all. In a study of 2021, Scottish physicist Hugh Hudson claims that the radiation from the Carrington flare contained the energy of 10 billion 1-megaton nuclear bombs. But 10 times more powerful flares can occur approximately every 3,000 years. And every 6,000 years, the sun flares up 100 times stronger. Sooner or later, our Earth will definitely not escape a crushing blow from the star. Charged particles will reach us in less than a day and rain down all over the planet. They'll lead to excess current in our electrical grids, which will cause colossal power surges. Power plants and substations will fail, and fires will start everywhere, which will be quite challenging to put out without means of communication. Many areas will remain without assistance for months. The heating and cooling systems will stop working. There will be problems with clean water. We'll have to turn off life support machines in hospitals. Solar flare that seems so far away will affect millions of people. You'll say some other light source may be, if not better, at least calmer. Scientists have already discovered an incredible number of stars, but not every one of them can suit us as does the sun. So what does it take to live up to its high standards? The answer to this question is precisely known in the SETI project, where almost 120,000 stars were studied within 1,000 light years, and they compiled a catalog of more than 17,000 HAB stars. Those are stars that can potentially have a habitable planet around. All of them meet specific criteria. Its age should be at least 3 billion years. Stars aged about 4.5 billion years are the most stable. The temperature shouldn't differ from the sun by more than 50 kelvins. That is, it should be about 5,800 kelvins. Its brightness cannot change by more than 1%. There must be enough dust in the circumstellar disk to form new planets with the possibility of life on them. And also, it shouldn't have a companion star with an orbital period of less than 10 days. Otherwise, it could lead to a change in the orbit and even collisions. And despite the fact it was impossible to detect a solar twin, we know what objects we should definitely be afraid of. So, in 2014, with the help of a special telescope for studying distant galaxies, NASA NuSTAR, astronomers discovered the brightest star that burns with the energy of 100 million suns. The super powerful source, M82X2, turned out to be an X-ray pulsar. This type of star is not only very powerful, but also compact, like two of our suns compressed to a diameter of 20 kilometers. With the strongest magnetic field in the universe and an atmosphere of particles that move almost at the speed of light, they almost don't emit visible light, but give planets a powerful radiation flux in the X-ray range, which is detrimental to all living things. Ordinary pulsars rotate at a speed of up to 60 times per second, or up to 700 times per millisecond. And with each movement, they send light into space as impulses. Will life be possible on a planet with a pulsar instead of the sun? Dutch astronomers Alessandro Patruno and Mikkel Kama claim that a pulsar's habitable zone can last for billions of years. Of course, due to the radioactive radiation, the pulsar is more aggressive and faster than any other star and may destroy Earth's atmosphere and water. Hydrogen from the atmosphere will quickly escape into space, but we will receive energy in the form of X-rays and pulsar wind with charged particles, and when it enters the atmosphere, it'll heat it up. To absorb dangerous X-rays and gamma rays, we need a stronger atmosphere, at least 3 times denser than now. But Earth is simply not designed for such weight and will immediately go out of orbit. If we imagine it still withstood the load, its pressure will increase precisely 3 times. In this case, life on the surface would develop in the same way as at the bottom of the Mariana Trench, the deepest place on Earth. Then the organisms would look like huge unicellular xenophyophores living at the bottom of the ocean, where there's little oxygen, a lot of pressure, and absolutely no sunlight. But does light always equal life? In 2019, with the help of the Hubble Space Telescope, scientists managed to take a picture of the brightest object in the universe. It became the quasar J043947. Its brightness is 600 trillion times greater than that of the Sun. But between it and the solar system, there are almost 13 billion light years. Therefore, they accidentally noticed it from the other side of the universe. It happened when a galaxy flying between it and Earth created the effect of a magnifying glass. So why aren't we still considering it as a backup option? The problem is that quasars only look like stars. In fact, these are nothing more than well-camouflaged supermassive black holes at the center of young galaxies. They intensely absorb everything that approaches them. Their victims emit this incredibly bright light, representing a real danger for us. Radiation causes disruptions in communication systems, while gamma radiation causes burns in humans, mutations in the genome, and leads to cancer. But its radiation would be the least of our problems if we found ourselves in the same galaxy with it. Every second, this black hole absorbs space matter comparable in mass to our planet, and its incredible gravitational force can attract not only planets, but also stars. If the brightest objects in the universe are deadly for us, what would our life look like near the most ordinary star, but the one that would be the exact opposite of the Sun? Our Sun belongs to a category of small stars known as yellow dwarfs. This seems unfair because it has a fairly impressive size. Its diameter is more than 100 diameters of Earth. But an even more incredible thing is that many objects in the universe are much larger than even our Sun. One such star is the red supergiant Betelgeuse. If you put it in the place of the Sun, it'll fill up all the space up to the orbit of Jupiter. It's 105,000 times brighter than the Sun and almost 1,500 times larger. But the light of red supergiants is unstable. Their rarefied outer layers pulsate all the time. Pulsating, Betelgeuse even changes its size. It increases to 800 diameters of the Sun, then decreases to 500. Its brightness changes in cycles that last for 425 or 185 Earth days. But there are also inexplicably long ones, lasting almost 6 years. Scientists suggest that a habitable zone near such a star could be at a distance of 22 astronomical units. That is, 22 distances from the Sun to the Earth. The planet must also have a powerful magnetic shield, otherwise the stellar wind will easily blow away the entire atmosphere from it. But even under these conditions, the surface temperature will gradually increase. At first glance, this isn't scary. After all, according to scientists 100 years ago, people were much less adapted to the heat. But in this case, even such a superpower is unlikely to be useful to us, because as the atmosphere warms, the concentration of carbon dioxide will increase. Due to the greenhouse effect, a large amount of water will escape from the stratosphere into space. The atmosphere and evaporated oceans will envelop the entire planet as a mixed steam gas mass. Its permeability to the Sun's rays will be very weak. So Earth will be shrouded in darkness. Only shallow oceans will remain liquid, but they'll consist of dense salt solutions. But if red giants are so inhospitable, their opposites may be more suitable for living next to them. What do you think? The blue-white supergiant Rigel shines at the other end of the Orion constellation. Its temperature is 11,000 degrees, which is 3.5 times more than Betelgeuse's. However, its radius is almost 18 times smaller. It's not only the brightest star in the constellation, but also the most powerful one. Rigel radiates 40,000 times more energy than our Sun. It's not surprising that it was known as a guiding star in the past. Due to its high temperature, it radiates intensely in the ultraviolet and X-ray ranges. And for us, that means the instant death of all living things. After all, the speed of its radiation flux is 15 kilowatts per square centimeter, and this vaporizes all objects at a distance of 150 million kilometers. In an environment dominated by such intense radiation, everything must be gigantic. A giant star, a giant planet, and giant distances between them. But if the differences in masses between the two bodies is slight, both of them could be in mutual tidal capture. When the planet always faces its star with only one side, it might lead to scorching temperatures on one side and permafrost on the other. But if we imagine our Earth will be in its place, even scientific and technological progress won't help us survive. The thing is that iron-nickel alloy prevails at the core of our planet. The temperature on the bright side will be enough to evaporate the iron on one side of our planet and drive it into the dark part with violent winds. There it'll instantly cool down and fall to the ground like an iron hail. Scientists are in a hurry to reassure us that there are definitely friendlier stars in the universe. In 2016 and 2017, astronomers discovered an entire planetary system of 7 Earth-like planets in orbit around the star TRAPPIST-1. But so far, neither an atmosphere nor magnetic field has been found on them. Yet 3 of them are in the habitable zone, where the amount of heat is sufficient for water to exist on the surface. One of the most impressive things about each is the view of the other 6 planets in the sky. In some cases, a nearby planet may appear to be twice the size of the full moon visible from here on Earth. These 7 twin planets could be in such close orbits because their parent star is an ultra-cold dwarf. It's about 2,000 times dimmer than our Sun, and most of its light is emitted in the infrared range, not in the visible one. Therefore, although the planets orbit very close to their parent star, natural light on them will seem very dim to a person. The planets make a complete revolution within the period from 1.5 to almost 12.5 days. The orbital period of the most distant planet is believed to be about 20 days. This means 1 year, or what scientists call an orbital period, on most of these planets is less than 2 weeks on Earth. Even if the years in the TRAPPIST-1 system are short, the days will be almost eternal, because all 7 planets are tidal ones turned to each other with only one side. They may need another star to balance the system. So what would we do if we had 2 suns? For scientists, this is no longer a question. Since 2011, they've regularly discovered such circumbinary planets that revolve around 2 or even 3 stars at once. Earth also could revolve around 2 stars, which also moved around each other. Together, this will form a binary star system. There are many options for the arrangement of stars and planets in such a system. For example, if both stars are dimmer than the Sun, the average temperature on our planet will drop to minus 73 degrees. Water will be frozen, and life will hardly be able to exist. And if the stars are brighter, our Earth will turn into a desert. But if both stars are gravitationally connected and turned toward each other with only one side, less radiation will hit our planet, and we'll have every chance to keep both the atmosphere and water on it. Stars in binary systems can significantly slow each other down and reduce the intensity of the stellar wind. If there were two suns in our system all this time, even Venus could have saved its water. But the balance will be maintained only if both stars are the same size. If one of the suns is larger and brighter than the other, it'll have a strong gravitational effect on Earth and will burn because it'll draw us too close to it. And if both suns, on the contrary, have an insufficiently strong gravitational field, Earth will immediately fly away into outer space. Our orbit can only remain stable when the planet revolves around two suns close to each other. Otherwise, Earth, in order to avoid a collision with one of the stars, will have to settle down outside the habitable zone. There, the sun's heat won't be enough to keep water in a liquid state. And in this case, Earth will turn into a cold, lifeless rock. But our sun has always done a great job of killing everything nearby. According to scientists, at the beginning of its life, it rotated 10 times faster, and it was then that its stellar winds blew away the atmosphere from the surface of Mars and destroyed its magnetic field. The sun will definitely reach us sooner or later with its flashes, but we'll already be fully armed with a supply of food, water, and a generator. And most importantly, in a safe place with no earthquakes, hurricanes, or tsunamis, but a lot of coolness, shade, and oxygen. I'm sure the sun won't even notice us in the giant forest grove. Due to the specific structure, the massive sequoias growing there are unique. They do not ignite or rot. This species appeared on Earth almost 200 million years ago. They survived dinosaurs, acid rain from asteroid impacts, and the Ice Age. They definitely have some kind of survival secret, and I hope they share it with people. When the giant solar flare heads towards Earth, I'll be waiting for you there. Meet me near the President, one of the oldest trees in the world, over 3,000 years old. And now that we have some time, you can suggest your options for safe places in the comments.